In this video, we are going to talk about numerical integration, and we have a problem that we have to evaluate this integral ln x dx, where the lower limit of integral is 4 and the upper limit of integral is 5.2, such that there are 7 ordinates in the whole data. So we are using numerical integration to solve this integral. Let's extract the information that we have got. Usually we find this integral y dx. Starting x value is x naught and ending x value is xn. And in our case, we have to find this integral ln x dx starting from 4 ending at 5.2. Let's compare these two integrals. So we can see that y in our case is ln x naught is 4, the starting x value, xn is 5.2, the last x value. We don't know what n is as of yet, but the last x value is 5.2, which we are denoting by xn. So this is the information that we have extracted from this integral that we yet have to solve using numerical integration. Now let's look at the statement. We have to evaluate this integral such that there are 7 ordinates. So ordinates are y values. If we have this information that there are 7 ordinates or 7 y values in this whole data, and remember that we start denoting our data from y naught or x naught. So if there are 7 values, 7 y values, first we will put just 7 dots. 1, 2, 3, 4, 5, 6, 7, because we have been told that there are 7 y values, and then we will name these values. We start naming it with y naught, y1, y2, y3, y4, y5, y6, and we call the last y, which is y6, as yn. This tells us yn is equal to y6, which tells us that n is 6. Now see the information that we have. X naught is 4, xn is 5.2, n is 6, and y or f of x is ln x. We know that we use numerical integration here for equally spaced data, and for equally spaced data we know this formula: xn is equal to x naught plus nh. Let's plug in the information that we have. The last xn is 5.2, x naught, the starting x, is 4, n is 6, h. So from here we can extract the value of h. 5.2 minus 4 divided by 6. So this gives us h equal to 0.2. Now that we have the value of h and we know the starting x is 4 and the ending x is 5.2, so we can compute the x values. Because if our data is equally spaced, we know that every next x value is obtained by adding h into the previous x. So first x is x naught, next would be x naught plus h, next would be x naught plus 2h. This is how we get x values if we know the starting x and h. So let's get x values. So starting x we know is 4 and h is 0.2. So next x value will be obtained by adding 0.2 in 4. We have 4.2, add 0.2 into 4.2, we get 4.4, and know that our last x is 5.2. So we'll continue to add 0.2 in the previous x's to reach finally 5.2. So 4.4, 4.6, 4.8, add 0.2 into this, 5, 5.0, and add 0.2 into it, you get 5.2. Let's name the x values, and remember that the last x should be x6 because n here is 6. Let's see that. x0, x1, x2, x3, x4, x5 and x6, which is the last x. And we know that in our case the function or y is equal to ln x. We have taken y equal to ln x from this integral that we have to calculate. So if we have the x values and we have the function, we can easily get the y values. So when we put x equal to 4 in ln x, we get 1.38629. So we have fixed our calculator up to 5 decimal places. For 4.2, we get 1.43508. For 4.4, we get 1.48160. For x3, that is 4.6, we get 1.52606. For 4.8, we get from ln x 1.56862. When we plug 5 in ln x, we get 1.60944. For 5.2, we get 1.648866. So now that we have x values and y values, we have the value of n, which is 6, and we have h, which is 0.2. Let's plug in these values in Simpson's 3/8 formula. So Simpson's 3/8 formula is, we solve the integral y dx x0 to xn, and the formula is 3/8 h y0 plus 3 y1 plus y2 plus y4 plus y5 all the way to yn minus 2 plus yn minus 1 plus 2 into y3 plus y6. In this part we have multiples of 3 subscripts plus yn minus 3 and the last value yn. This is Simpson's 3/8 rule of integration, and know that n must be in this case multiple of 3. So if n is other than multiple of 3, we cannot apply Simpson's 3/8 rule of integration. For example, if n is 2, we cannot apply Simpson's 3/8 rule of integration. For n equal to 2, we will have to apply Simpson's 1/3 because Simpson's 1/3 works for even n. So can we apply Simpson's 3/8 rule for our case because our n is 6? Yes, 6 is the multiple of 3, so we can apply Simpson's 3/8 rule of integration here. So we have to evaluate the integral ln x dx. Starting x is 4, ending x is 5.2. Let's plug in the values. N equal to 6, h was 0.2, and we have the y values. So 3/8, h is 0.2, integral. We will first put the last y value, yn. N is 6, so we have y6. So after y6, let's look at this part which has multiples of 3 subscripts. So you have the last value yn minus 3, it goes all the way back to y3. So for yn minus 3, since n is 6, so here we have n is 6, so 6 minus 3, it is y3. This part says yn minus 3 is the last value and it goes all the way to y3, but we got y3, so we'll just put it here and then close the bracket. Outside we have 2 plus, and now the part which is being multiplied with 3. So the last value in this part is yn minus 1. So n is 6, 6 minus 1 is 5, plus yn minus 2, n is 6, so 6 minus 2 is 4, so we have y4, and this part says yn minus 1 plus yn minus 2 and goes all the way back to y1 plus y2. So we have y5, y4 plus behind y4 we have y3. So for y3, its base is the multiple of 3 and multiple of 3 subscripts y's are put in this part. So we have already covered it here. Here y5 plus y4, y3 is covered here. Then we have y2 plus y1, we close the bracket, multiply it with 3 plus the initial y value which is y0. So let's put in the y values now. So we will put the y values from here. Let's name the y values: y0, y1, y2, y3, y4, y5, y6. So y0 is 1.38629 plus 3, y1 is 1.43508, y2 is 1.48160, y4 is 1.56863, y5 is 1.60944 plus 2 into y3 which is 1.52606 plus y6 which is 1.64866, and we close the bracket. So we calculate this inside sum, multiply it by 0.2 and 3 divided by 8, and we get 1.82785. So we have just solved this integral ln x dx, where the starting x was 4 and ending x was 5.2, by using numerical integration, in particular by using Simpson's 3/8 rule of integration. Just know that Simpson's 3/8 rule of integration works for n which is multiple of 3.